Hello, Kevin. How are you doing today? I hope you had a good weekend. Okay, today's topic is going to be on derivatives. And as you see the question on the whiteboard, it says find the coordinates of the stationary points of the curve y equals x cubed minus 6x squared plus 9x plus 1. Okay, we're going to use the first step. We're going to use the general formula of derivatives, which is y equals nx to the power n minus 1. So we're going to start with the first variable, x cubed. So x cubed, we're going to differentiate x cubed, and that's going to be, we're going to subtract 1 from 3, the exponent, and multiply 3 by 1, multiplying x, that will give us 3x squared. So we're going to move to the next variable, which is 6x squared. And so we move to the next variable, 6x squared. So we multiply the exponent 2 by 6. We get 12. And we subtract 1 from the exponent 2, we get 1. So it's going to be 12x. Then for 9x, we get 9 because x is the same as x to the power of 1. We multiply 1 by 9. We get 9. And we subtract 1 from 1 will give us 0. So that will be just 9. So the constant 1 is going to go to 0 because x to the power 0 multiplying 1. When you multiply 0 by 1, you get 0. So that leaves it with, that eliminates 1. So this is going to be a quadratic equation. And to find the stationary points, dy dx must be equal to 0. So this expression, 3x squared minus 12x plus 9, is equals to dy dx. So the next thing we're going to do is equate 3x squared minus 12x plus 9 to 0. But we can simplify, we can reduce it to lower terms. So if you divide through by 3, you're going to get y equals x squared minus 4x plus 3. So that's going to be the next step. Y equals 4x plus 3. So let's move up here. We're going to find, this is a quadratic equation. We're going to find the factors of this quadratic equation. So this should be equal to 0. That should be equal to 0. So we're going to find the factors of this quadratic equation, x squared minus 4x plus 3. So we to find the factors, you multiply the coefficient of x squared by the constant 3, which gives us 3, and you find the factors of 3. Factors of 3 are 1 and 3 and negative 1 and negative 3. And when you add that, you get the middle coefficient, negative 4. So negative 1 and negative 3 are the best choices. So when we put that in parentheses, x minus 1 and x minus 3, it will give us the factors of x squared minus 4x plus 3. So this x minus 1 equals 0. When you add 1 to both sides, you get 1. Same way, x minus 3 equals 0 because we're solving for x. So when you add 3 to both sides of x minus 3, because we want to isolate them and solve for x, so x will be equal to 3. So we now have to find the y coordinate of the stationary point. So we substitute 1 into the curve, x cubed minus 6x squared plus 9x plus 1. So 1 cubed will give us 1 there. minus 6 times 1 squared is going to give us 6, plus 9 times 1 give us 9 plus 1. And when you do the arithmetic here, 1 minus 6 plus 9 plus 1, 1 minus 6 is negative 5 plus 9 is 4 plus 1 is 5. Kevin, I hope you have it. Let me know if you have any questions. You want to know why I'm substituting what x equals 1 into the curve y? Yeah, because they are stationary points and you have to find both coordinates, x and y coordinates. So I hope that answers your question. So for the point x equals 3, we're going to get y equals 3 cubed. That's going to give us 27 minus 6 times 9, 3 squared. 6 times 9 is 54. Plus 9 times 3 is 27 again. Plus 1. So when you add 27 plus 27 gives us 54. When you subtract that from 54, you get 0 plus 1 leaves us 1. So these are the stationary points. So the stationary points are 1, 1 and 3, and 3, 1 and 5, I beg your pardon, and 3 and 1. So these are the stationary points. And here it just tells you that the curve is like a gradient. It's a gradient around the curve, and it starts from the third quadrant in the x and y plane, the negative x and y and negative y plane, negative y plane, and it goes. The gradient increases, and when it gets to the curve 1, 1, 5, the gradient is 0. It's a tangent to the line. It's a horizontal line where the gradient is 0. So that's how we find the stationary points. That's another way of finding the stationary points. So I hope this explains the whole problem. Let me know if you have any questions, and I hope you enjoy the class. Thank you very much.